Psychology is the study of the mind and behaviour. It asks questions such as, how do we learn and make decisions? Why do we help and sometimes hurt other people? And how do our thoughts and emotions shape the way we live our lives? The research it produces can influence everything from education and healthcare to law, marketing and workplace design. But because psychology studies something so complex and personal, i.e. us, a question that comes up time and time again is, does it really count as a science? Well, to answer that, we first need to take a look at what science means, and then see how psychology stacks up. People tend to think of science in terms of test tubes and telescopes, but in reality, it's a systematic way of asking and answering questions about the world. Science starts with empiricism, the idea that knowledge comes from careful observation and measurement, and that's as true in psychology as it is in physics or biology. The difference is, instead of studying things like galaxies and cells, psychology studies how humans think, feel and behave. Like other sciences, psychology uses a process that moves from observation to theory to prediction and then to rigorous testing. In psychology, this process is characteristic of what we call the quantitative approach to research. For example, a psychologist might observe that when asked to recall a list of items, people tend to recall the items at the start and the end of the list more readily than the items in the middle of the list. Over time, repeated observations like this are organised into a theory, which is a broad explanation of how and why something happens. In our example, a psychologist might theorise that items at the beginning of a list are rehearsed more and therefore transferred to long-term memory, whereas items at the end of a list are still fresh in short-term memory at the point of recall. Theories like this give researchers an explanatory framework, which they can test, refine and challenge with new evidence. From a theory comes a hypothesis, which is a specific, testable prediction, which should be supported by the evidence if the theory is accurate. For example, people will remember the first and last two items on a list more frequently than items from the middle of the list. Next comes the research design, or plan of how to test a hypothesis. This means making a decision about the method being used, for example, asking participants to remember a list of words. It also means deciding on the measure used, for example, the proportion of words correctly recalled by the participants. Finally, it means considering other variables that need to be controlled for, such as the amount of words that appear on the list, and the amount of time that each of the words is available for the participants to view. Then comes data collection and analysis. In our example, this would involve conducting the study, then recording participants' recall scores before subjecting that data to statistical tests that would determine whether the data supported our hypothesis. After that comes scrutiny. Research doesn't generally make its way directly from the lab notebook into a publication. First, it tends to be peer-reviewed, which is where a panel of experts examine the study for flaws in its design and in the analysis and interpretation of its data. A piece of research is only generally accepted for publication after it's got through the process of peer review. But a single study only tells you so much. Science requires that a finding can be consistently demonstrated before it's considered reliable. This is where replication comes in. Repeating a study to see if a similar pattern of results is observed. Replication builds confidence that an effect, such as participants being better able to remember the first and last items in a list, is real and not simply a fluke. The process we've just identified is grounded in the concept of falsifiability, which is the idea that in order for a claim to be considered scientific, there must be some result or observation that could be used to refute it. For example, our claim that people tend to most readily recall items at the beginning and end of a list would be refuted if the data suggested that people were most accurate in remembering items that occurred in the middle of a list. Of course, not all research in psychology follows the hypothesis testing path. Some research questions can be better addressed by getting people to share their experiences rather than predicting outcomes in advance. That's where qualitative research comes in. Like quantitative research, qualitative research still follows a systematic process, but the steps involved in that process look a little different. The qualitative approach begins with an observation or the identification of a topic. Let's say, for example, that a lecturer notices that upon receiving feedback on their first piece of work, some first-year students appear very discouraged, whereas others seem highly motivated. The next step in the process involves setting the research question. In qualitative research, the research question is the compass for the entire study. It needs to be open enough in order to capture the richness of the topic being studied, but it needs to be focused enough to guide data collection and analysis. In our example, we might set a question like, how do new first-year psychology undergraduates experience academic feedback? Next up comes the method selection. In our example, the researcher might choose to use a semi-structured interview or conversation guided by question prompts that are open enough to give the student a chance to talk about their experiences in their own words. Qualitative research also uses other methodologies such as focus groups, but the key is always the same, to gather detailed information about people's experiences and perspectives. Then comes data collection, in which the researcher gathers in-depth information from a relatively small number of participants. Unlike quantitative research, qualitative work prioritizes richness and depth of information over sample size. After this, the researcher chooses an approach to the analysis that fits the research question. For example, thematic analysis if the intention is to identify recurrent patterns, discourse analysis if the intention is to discover how language shapes experiences. In our example, let's suppose that a thematic analysis reveals certain themes that seem to distinguish students who find feedback demotivating from those that find it highly motivating. Such themes might include the clarity of the comments, the tone in which they're written, and whether they contain helpful, specific suggestions or just vague advice. During the analysis stage, researchers also engage in reflexivity. That's to say that they reflect on how their own assumptions or expectations may impact on their interpretation of the data. Finally, the researcher writes up the study as a publication. They explain the coding process, make the interpretations transparent, and show how their interpretations fit in with existing research. The paper is then submitted for peer review, where a selection of experts scrutinise the work and decide whether it should be accepted for publication. So as with quantitative research, qualitative research aims for rigour, transparency, and evidence-based conclusions. It just focuses on words, meanings, and context for its data, rather than numbers and measurements. Whether we're talking about the quantitative or qualitative approach to psychological research, psychology's key strength is in building knowledge step by step. Always grounded in evidence, always open to scrutiny. These are two key characteristics of science, irrespective of the subject matter being studied. So is psychology a science? Short answer, yes. Sure, it can be messy because, well, people are messy, but it's still grounded in systematic, evidence-based inquiry. And ultimately, that's what makes it a science. Of course, to really understand psychological research, we need to know more about research design. So in the next episode, we'll be exploring the main types of research design, and we'll see how each type of design can help us address different questions. So make sure you don't miss the next episode, hit that subscribe button, turn on those notifications, and I'll see you there.